Hey everybody, it's Norm from Tested, and today I'm going to be reviewing Valve's Steam Machine. The Steam Machine is finally here, and in fact, as we're publishing this video, Valve has not only announced pricing for Steam Machine, which we'll definitely talk about, but also the availability as well. There's a reservation system in place for people who are interested in pre-ordering one. There'll be a random drawing for that reservation system, and we'll have links and details in the description below. But today I want to talk about the design, the attributes of the Steam Machine, how it's performed in the week and a half that we've had to test it, and where SteamOS as a gaming operating system has come and how far it's come since the first time we were really exposed to it with the Steam Deck. And maybe the Steam Deck is a great place to start because as it was released a couple of years ago, we really were uncertain about the viability of Linux and Steam as a gaming operating system, compatibility with the Proton compatibility layer. But all that kind of has changed. Steam Deck is very successful, very popular. We love using ours, not only on the go, but also in the home. You can have it plugged into the dock that Valve sells or number of third-party docks available. Use it not only as a gaming device, but also as an actual productivity computer in the desktop mode, or what I do, have it in the living room, plugged into my big screen TV, playing games not only natively with the Steam controller, but also streaming games from my desktop gaming PC in the house. And Valve knows that. A lot of them as well have the Steam Deck plugged into their TVs, and so that gave them reason to design and make a Steam machine. Now, the performance target for the Steam Machine, they told us, was kind of entry to mid-level. They wanted to be able to play 4K games, at playable frame rates using upscaling. And a lot of that performance target has informed the components they've chosen as well as the design of this that they're able to make, because it's a very compact device. That's the first thing. This is a very small machine. The nickname for it is the Gabe Cube, but it's not quite a cube. It's a little bit wider than 6 inches, a little deeper, about almost 6.5 inches deep, 162 millimeters, but definitely under that 6 inches in height, even with the risers, the feet. It's 152 millimeters in metric. And that means it does fit into at least my home entertainment center and console, and most people's as well. But in the small form factor gaming PC world, you do the math, and the volume of this is 3.8 liters. That's minuscule. Anything under 20 liters is technically considered small form factor. By point of comparison, a mini ITX board is 6.7 inches square, and so the footprint of Steam Machine is already smaller than the footprint of a mini ITX board, to give you a sense of how small this machine is. And it's not just the size of this and the volume of this and where you can put this in the house, but also how Valve designed the cooling around it. Because if you take off the shroud and disassemble the machine, you see that most of this is one giant heatsink. Most of the components for the processing is in the bottom, but this is all cooled by one 120 millimeter fan in the back, custom design, and then all that gaming hardware is in the bottom, which means it operates really quietly. Now, to achieve that performance, Valve has once partnered with AMD for their components, and unlike with the Steam Deck, it's not using an APU, shared GPU, CPU memory system here. It's discrete CPU and discrete GPU. CPU is based off of AMD's Zen 4 architecture, 6 cores, 12 threads here, up to 4.8 gigahertz, and that's running on 16 gigabytes of DDR5 memory, split across 2 SODIMM laptop modules, essentially. The GPU is more interesting. It's a semi-custom part, Valve says, running off of AMD's RDNA 3 architecture. This is Navi 33. And so with 28 compute units, it's a little bit less powerful than the RX 7600 card that AMD makes. And the TDP here, as we've tested, never went above 110 watts. And so the whole machine kind of operates CPU, GPU at load with all the I/O and everything plugged in at well under 200 watts. We basically measured it close to like 180, 185 watts at load. Now, with that custom design where it's mostly heatsink, one fan in the back, intake in the front and underneath, all that hardware is kind of stacked on boards near the bottom of the machine. So to achieve that design, as well as the goal of user serviceability and some minor upgradability, you can access the storage as well as the memory. Valve had to make choices and decisions for the I/O, for the input and output for the machine. So you have in the back, you have the power cable, and the power supply is built in, a 300-watt power supply inclusive in this volume. But video out is HDMI 2.0, that's with CEC, so you can use it to actually turn on the TV you have it plugged into. DisplayPort 1.4, which gives it some versatility in plugging things like VR headsets or gaming monitors or even things like display glasses. And then 4 USB-A ports, but it's split between 2 USB 3.0 in the front and 2 USB 2.0 A ports in the back, and only 1 USB-C port. And that USB-C port doesn't have DisplayPort Alt, so you can't plug in a monitor directly into that port. There's also Ethernet as well, and then for expandability, a micro SD card in the slot in the front, and that's the same micro SD card slot that you find in the Steam Deck, meaning that the storage that you have, the games that you have stored on your Steam Deck, you can literally take that card out, plug into the Steam machine, and the library will be recognized in SteamOS. And plenty of wireless radios, so it can connect over Bluetooth for devices like keyboard, mouse, headphones, gamepads, as well as having 2 Wi-Fi radios and 1 dedicated receiver for Steam controllers. You can pair up to 4 Steam controllers directly to the Steam machine, so you don't have to use the charging dongle, the chongle, and dedicate that to some other gaming PC you have in the house. No microphone or headphone jack, which is an interesting decision. But in taking apart the machine, not only did we see the SSD right at the bottom, it's a 2230 size M.2 SSD here, but you can replace it with a 2280 size longer stick of storage. And if you have a 2 terabyte stick from the before times for things got really expensive, very easy to swap that in. The RAM is accessible, but a little harder to get to. You have to disconnect some of the daughter boards, and in removing those components, I did find that it is very serviceable and accessible. It's just torque screws via the bottom and the back to get into the machine, and everything's pretty well labeled, and putting things back together wasn't a problem. Valve is partnering with iFixit again for components, and so as custom and tightly packed as a machine this is, and it really still is very user serviceable, if not fully upgradable, because you can't swap out the GPU, CPU, or upgrade VRAM, for example. There is some level of customization you can do. So this faceplate, for example, magnetically disconnects, and on the 2 terabyte models of the Steam machine, Valve is also including 2 alternate faceplates. So there's this walnut wood one, which will pop on, looks classy in a living room, and then this interesting kind of velvety, soft, deep orange one, which is striking, but I found an interesting choice for Valve to put out as a pack-in alternate faceplate. The design for these faceplates will be made available, the CAD design, so people can 3D print and model their own, but there's no access to power or data in the front here if you wanted to make a faceplate as an external display, or have some type of interesting active use other than just like a passive shroud that you put in the front. You can see in the front there's also this bar of LED lights. It is RGB LED, and you can, in SteamOS, adjust what the bar does. So it can be a solid color, it can be a breathing, pulsing light, a patrol light that goes back and forth. You can adjust things like brightness and the speed at which it animates, but there's no plugin system in place for it to tap into system information. It does work as a kind of status indicator for downloads, so you can see it if you're downloading in SteamOS. That's a really cool feature to see your downloads, how far it's progressing. But I would love for people to tap into other things, things like fan speed or power consumption, or even something in a desktop application. But we'll leave that to third-party software modders and developers to potentially tap into. It's a very open platform. I did want to ask Valve about their choice of hardware, how they achieved this specific design and form factor. So before we get to performance, let's jump to an interview I did with Valve's design and hardware engineers about the making of Steam Machine. Well, it's been a little over half a year since I got to visit and check out Steam Machine, this iteration of Steam Machine for the first time. But for you guys, it's been, I imagine, a multi-year journey. Can you remind the viewers out there, when you guys started this project and what the goals were, and back then, computer and gaming industry being, and the hardware business being a little bit different, what you anticipated and hoped for Steam Machine?
Yeah, for sure. When we started, after Steam Deck OLED, we had a lot of the elements that make today's Steam Machine experience, right? And it was pretty clear that it was, with the dock and folks were already having that living room experience with the deck. It was pretty clear that it was something that we could do as a next step, right? So we started building a bunch of computers from parts to try and just get an idea of what it would be like to have an experience in the living room that has a little bit more horsepower to work with, so that you can play games at high resolution, and make use of all those kind of advanced, technologies with VRR, ray tracing, and all that stuff. Mm-hmm. And so it took us a little bit of that before we got to a performance target that we liked, that we thought could play, all the games on Steam with a good experience. And then we worked from there, into, making it into a smaller form factor. I'd say that the development cycle is probably, 3 years for like the prototyping aspect of it, and then to turn it into a product, and then, start building the thing that now as Steam Machine. That's probably been like the last year and a half or so.
So 3 years ago, you're looking at performance targets, you're looking at form factors. Those things have to intersect at some point. What do you know back then about what type of hardware will be available? Like, when do you start having to commit to not just performance, but components, and working with your partners to make sure things like the GPU and CPU are going to be available at the quantities and prices that you want at that point?
Yeah, definitely at this early stage, you're not really thinking about that aspect of it, right? It's more about you're looking at the performance and the experience, trying to work back from what the user will experience. So it's more like, the maybe 2 years ago, year and a half mark, where we're starting to be like, okay, we got to establish those, supply relationships, make sure you have, multiple suppliers for everything, for memory and stuff. But at that point, you're probably, I mean, one thing that we had in mind from the beginning from Steam Machine is we wanted to be able to build it from parts that already exist for PC, as opposed to doing something custom that has a longer lead time, right? And so it's a decision we made pretty early on, and at that, there's not that many offerings that are in the performance target that we were looking at, and so then we started looking at price to try and see what generation we should be targeting and all that.
Yeah. One of the interesting aspects of this being a small form factor PC is that you guys didn't choose to go with like an APU. You guys decided to go with CPU and discrete GPU. Can you talk about that choice and how you chose those separate components, both from AMD?
Yes, that was actually pretty straightforward, because an APU is actually the natural choice, right, for a product like that, a system like that, because you can be a little bit more efficient with things like power usage, but also importantly like thermals, right? And you're just a little bit more efficient there. But we looked at what was in the market in terms of APUs, and you had all the laptops platforms, right? The AMD APUs that you're familiar with. And then, on the horizon, you had things like Strix Halo. But when we looked at that, Strix Halo is kind of at the performance target that we were looking at, but it would have been a much more expensive platform for the same performance. And so it was pretty early on that we concluded, okay, we have to use discrete parts, and then found something at that performance target as well.
Is it true that the CPU that you've chosen is a version of AMD's APU that you've just only decided to use the CPU core parts for?
Well, I guess that's I think down to AMD's internal management of SKUs and all that. So I don't know exactly how they consider it internally, but yeah, my understanding is it's what they call a mobile platform.
Hmm.
Um, but at the end of the day, we looked at face value with like how many cores do we get, what clocks they can they can achieve and sustain, and what is the performance that we're looking for. Uh, it has always been the case that especially compared to offerings on the market that are trying to be more all-rounders, productivity PCs, that for something that's gaming focused, we always like the ratio between CPU and GPU, I think for a pure gaming oriented system is going to be a little bit different than something that you're getting for the mainstream. And so we wanted to make sure that we weren't overbuying on the CPU side so that there's still good value there, which
Yeah.
I think has driven our choice of CPU platform.
Yeah. How did you guys end up at 8 GB of VRAM as the target or the sweet spot for this machine?
It's a little bit similar, just based on testing, right? I think it was a decision that we took very seriously because we were extremely aware that 8 GB was kind of, like that specs were getting increased there, and that newer GPUs had bigger amounts. But when we looked at the amount of GPU horsepower that we had to work with, and the experience that you would get realistically with that, it seemed to us, and I think this calculus still works today from what we've seen, but for the settings and the level, the resolution, the settings you would want to play at, the 8 GB VRAM is actually a good amount for that. There are areas like you can make it run out of VRAM, but usually it's when it's by setting things that would not actually be a good experience, even if you had more VRAM, just on the baseline performance, right? And so that was our conclusion. Again, it's driven back from trying to deliver the best value, like 12
Mhm.
gigabyte, 16 GB VRAM, especially in today's world. But even back then, when we're looking at the price of components, back then, it would still have been a significant bump on the price. We didn't think it made sense with where we were trying to position the CPU and GPU power.
Do you also factor in what gamers are playing not only in their living rooms but on desktops and the type of AAA games and what engines require at 2.5K or 4K resolutions?
Yeah, I mean, we're looking at all that, but I think we approach it pretty
Yeah.
holistically, like the whole Steam library, right?
Mm.
If anything, I would say that the difference there on games that people might play more primarily on mouse keyboard desktop configurations are actually not, they don't tend to be as demanding. Like the online games that you're gonna definitely want to play on your desktop versus a platform like that, I would think they actually tend to scale a little bit better, right? So I don't think the picture was terribly different performance wise there on living room versus desktop.
Can you share more insights into the cooling design? Because one of the things I've noticed as I've been using it is just how quiet it is. Not only is it this compact form factor that fits in the entertainment center, but I can barely hear it. I know when we first saw it and have taken it apart, it seems to be very a robust cooling system.
I mean, the majority of the volume of the product is the heat sink, the thermal module, right? We arrived at that design through working back from what we wanted in terms of yeah, like the noise level and all that. We found that it's actually pretty complicated to have one thermal module, cool all these different components that have different elevations on the board, like interfacing it efficiently with everything is actually pretty challenging engineering wise. So the natural approach would have been to have, a couple of smaller thermal modules with smaller fans, but we found that being able to combine everything gives us more headroom, which then, means that we don't have to cool as much. But more
Mhm.
importantly, if you can put a 120 millimeter fan on it, you don't have I mean, it's something that every person building a PC knows very well, right? The bigger the fan, the less noise you're going to have. And so we were pretty excited to be able to find a form factor that accommodated the 120 fan as its sole cooling solution because it achieves the very quiet result that you're experiencing now.
And I know that there was a lot of iteration and testing that led to that system as it is now, like the intake from the bottom, vent out the back, but even the front plate, like that's an intake
Mhm.
as well. And
Mhm.
just like fan placement led to different qualities of sound, but also different qualities of like how much it can actually cool things. So I know that there are a lot of different versions with fans and with the fan in different places. And given the small form factor, there's not very many places you can put it where it would make sense. So we're really happy with how it ended up.
Is it a relatively off-the-shelf actual fan, or is even the blade design something that went through your design process?
I think we customize pretty much every aspect of it, working
Okay.
closely with the vendor. Most of the customization is probably on the interface between the fan and the rest, like the connection point, the hood between the thermal module and the fan. But my understanding is everything down to, yeah, the attack angle of the blades and everything was
Yeah.
tweaked.
You mentioned intake, right? So I noticed that it takes intake from the bottom as well as from the front. I know people are probably going to mod these, and it's kind of made to be customized and personalized with different faceplates. What's your best advice for people adding accessories to ensure that you're still maintaining that good intake?
Yeah, I mean, I think one of the things we will want to remind people is don't put it on carpet. Just like customization aside, carpet is not a good place for this to be sitting on when you're using it. When we release CAD files for the faceplate design, we'll we'll include that with some best practices for make sure there's enough gap and make sure here's where you put the magnet so that you can place it here without it rocking. But yeah, I think basically don't block any of the intake
Yeah, which is
vents.
very much in line with what we had said for Steam Deck as well. We had some zones that were like, hey, don't cover this part if you don't want to
Yeah.
impact thermal performance.
Back when I visited, I think your engineers were talking about how you're still tuning the TDP for the GPU, and I see now it's kind of locked into 110 watt as maximum. Is that adjustable at all? I know on Steam Deck there's a manual GPU clock slider, but what's the overclocking potential, and is there headroom to clock this higher?
I'm not sure there's that much headroom. I think we pretty much want to set it to. That being said, I'm not entirely certain on the number there, so I don't know if the number you said is what we're actually running the GPU at. I would have to confirm that, but in general, I think we want to make sure everyone has the best performance that they can out of the box. So if there was performance left on the table, we would have because there's definitely there's no shortage of like cooling ability, right? The thermal module can handle a bit more. That's why it's so quiet when it's at load because there's actually headroom there. And so I think the GPU itself, from the power rails perspective, the power supply is being driven at the pretty much the max wattage that it can do. Um, for Steam Deck, I think there's a lot of value in those kinds of fine-grained controls to be able to tune things like power management and get to the best battery life.
Mhm.
But on Steam Machine, there's less reason to want to do that. So we're optimizing for performance for the most part.
In the time that since we first saw it, and now I'm sure you're iterating on SteamOS. I know SteamOS 3 has been out. Can you talk about the journey of SteamOS from kind of getting it to a good place on deck to what you need to do to make it work for Steam Machine and other potential computers that people are building?
Yeah, I mean it's pretty straightforward. I
Yeah.
think even with Deck, back then, I think the SteamOS experience very similar to what you're seeing now with the machine, but there was a point after deck release where we had a bunch of work that was focused on improving the docked
Hmm.
experience, right? And some of that work went into the dock itself. We did firmware updates and all that, but a bunch of that work was in SteamOS, right?
Hmm.
And so a bunch of the work around controlling external resolution displays, adding good VRR support, and then later on, there's a few things that we needed to work on that were not deck applicable. Things like teaching our graphics driver and kernel to do better management of discrete GPU VRAM, right? Like being able to migrate allocations in a way that's optimal, but also doing things like tuning and optimizing ray tracing
Hmm.
performance. As it's not a feature that tends to get used a ton on the Steam Deck. So
Mhm.
we went through, a bunch of that work that is not not only applicable to a bunch of computers, but also a Steam Machine and I think and a bunch of UI polish as well, right?
Yeah. Yeah. I mean, a lot, like Peel was saying, a lot of the stuff that we had put in place for Steam Deck for the docked experiment experience, just translated directly to Steam machines. Like, what does it look like to use, and how do you use Steam OS and Steam with a gamepad on a big screen? And did you already mention CEC and things like that?
Right, yeah. See, we had some support for it on the dock, but we improved that quite a bit for machine as well.
Yeah. But like all of the stuff that we've been working on in the intervening time is not only improving, the interface for Steam Machine, but also all docked Steam Decks or big picture mode that is running on a big screen. So, it's a lot of many birds with one stone every time we make any of these updates.
Yeah. And I know SteamOS now supports, other vendors incorporating it and having it either pre-installed or users installing it. What's the state of SteamOS for people who want to build their own gaming PCs and with availability of hardware that's out there right now?
I think that if you want to build something that's going to be used like a Steam machine, right, where especially in a living room environment, that SteamOS is starting to be a pretty good fit now in terms of both the compatibility and also just the experience that you get, because it's very much in line with what you will get with Steam machine, minus a few points that are related to more of the hardware integration, like CEC support and the dedicated Bluetooth antenna and all that, right? But for stuff that you can build yourself, pretty much anything right now with a discrete AMD GPU would be a very good fit, right? So you can make your own Steam machine at different perf targets. You can make one that's less performant. You can make one that's, has 4 times the GPU power if you want. So the compatibility has increased a lot. We support all the latest desktop platforms in terms of CPU side. We're working hard on supporting Intel and NVIDIA GPUs as well, and that's been improving rapidly, but it's still a work in progress. So I think as soon as we think that there's a good experience there, we'll make sure to let people know. But so we've also done a little bit of work on the installation and all that. So previously we had the deck recovery image, but now it's more of a generic imager, right, that you can put on USB media. So if you're building something that's like a Steam machine where it's a gaming PC that's going to be used with a controller that you put under your TV. You get an SSD in, you install SteamOS, and then you're good to go. You pretty much have your own Steam machine. But just like the Steam machine can be used on desktop, if you want a desktop experience comparable to that, then that will work as well, just in the same way. And in the future, we want to expand on the desktop side, of course.
Yeah. Going back to what you said about support for Intel and NVIDIA specifically, a lot of users are curious about that. What are the technical or challenges in general of getting that support? Is it difference between how much they want to give control they want to give up, or how much control you guys want to have for driver packages, or what are the bottlenecks there?
I don't think it's much about control. In fact, the Linux graphics driver stack is such that everyone is working in the same code base, right? And so, I mean, in the past, there were vendor drivers where it's the same, model as Windows, where you would get a redistributable installer from the vendor or something that's packaged by the distribution. But these days, everyone's moving to the same model that we use on AMD, which is all the drivers are part of Mesa, and everyone's working in the same open source code base, right? And making sure they're just as good as possible. I mean, it's a little bit of a different situation for everyone. For Intel, the reality of the situation is that the hardware on the Intel side has progressed rapidly in the last few years, right? To the point where it's now very relevant to be able to play the latest games on Intel, but didn't really used to be. And because of that, the driver support was lagging behind a little bit, especially on the Linux side compared to Windows. And so I think there's a little bit of catch-up work to do, but we're working on it closely with Intel engineers that are working within that Mesa code base. And I think even just between now and the last 6 months, there's a ton of games that were, DX12 that didn't used to work very well, and now they run. The performance gap is being closed up. So all that stuff is following its course there. And we're pretty excited about where it's going, because the Intel hardware has been progressing rapidly in quality as well. For NVIDIA, it's a little bit of the same thing. The concept of using the Mesa driver for NVIDIA is a little bit more new, right? Compared to like the vendor model there was a little bit longer in the tooth, but in general, everything's moving that direction. And we have actually a team of dedicated engineers as part of our open source group that is working on expanding that. So it's the same thing. As soon as the performance is close to what we think users will expect from their hardware, then we'll be happy to call it a beta and then start from there.
When you guys unveiled Steam Machine, you also unveiled Steam Frame, and a lot of people in their minds feel like they would be a nice pairing, especially for playing flat screen games in a headset. How do you think of Steam Machine and its support for full PC VR games? I can use Steam Link and run something like Half-Life Alyx and stream it, but what about support for tethered VR experiences? And is that going to be improved?
Yeah, it's something that we're working on. I think, right now our focus is on Frame, right, to make sure that it's a great source for streaming content to the Frame. But you know, Steam VR has supported Linux for pretty much
the whole time.
for a while, and so I think there's some fixing and polishing that we can do to make sure the Vive and the Index are working fine there, and that people can also do things like streaming to Quest and all that. There's a lot of moving targets there, and it's all on our list. We want to make sure that's all supported. It's I would say maybe it's a little bit farther on the list, and making sure Frame is going to be great for streaming.
Just looking at the evolution of your approach to hardware, going from the very first versions of Steam Machine and even Steam Controller, back when there was also the Steam Link device, right? Is it fair to say that that approach of a streaming dedicated box, it's just the app now is sufficient for that, and it's not part of the thinking for hardware?
Yeah, the link hardware has basically just become an app, and it's available on many app stores now, right?
Yeah.
It's on.
Yeah, I think the conclusion back then was that the ecosystem of peripherals or of the devices where you could put an app did not have powerful enough SoCs to do the kind of high definition, high bandwidth, and low latency decode that you needed for Steam Link. So the device made sense. But then in the next few years, the hardware caught up, and even the smallest phones or the smart TVs had enough to, and that use case was becoming more prevalent. So it made sense to transition to software only.
Yeah.
I mean, these days we have, devices. I mean, the Steam Deck is a great streaming target as well, right? Steam Deck OLED, if you're streaming, you can get, 10 hours battery life. It's solid for that. And we're pretty happy how Steam Frame and Steam Deck will be great streaming targets from a machine. Likewise, machine might be a good streaming target from a monster gaming PC. Like, it goes both ways, really.
I want to wrap up with just talk about the cost of hardware these days and things that maybe no one was expecting, or you guys were just looking into the horizon back then when you guys were starting work on this. Well, know memory and storage is very expensive. Is there a consideration of putting out hardware where you let the users bring their own, memory and storage, or is the working out of the box experience really that important for you guys?
Yeah, it did came up.
Yeah.
I think, like you said, there's an inherent tension between the goals of something like Steam Machine and a bare bones PC kit, because part of the goal is removing the stress from figuring out what you need to buy, right? And how to set it up and all that. And so, I mean, it's one of the goals, not the only goal, but it's there. So shipping something that, requires you to bring your own parts would be a little bit difficult with that, but we've definitely thought about it. We even play tested the process of like, what would it be to get something that's not populated with system memory or with storage, and the difficulty levels of doing those various installations, right? The storage is extremely easy to get at, but the memory had some signal integrity constraints that required us to put it above the main board and not below. And so it's a little bit of like the procedure needed to unseat the thermal module, make sure all the flexes and the antennas, go back. I guess I would say it's closer to working on a laptop than working on a desktop PC. And we thought that was maybe a little bit too hard for some users. There's also a lot of production constraints. Like it's not clear how we would actually make the thing without memory in it, because we need memory to test it.
Yeah.
And so it's like now you're building it and you're taking it apart. We looked at it from many different angles, and it didn't quite make sense. We might still come out with something like that, or it might be the case that you can buy all the parts from iFixit and build your own. Like we're still trying to think about how to approach that. But right now it's a little challenging too, because the main board has the VRAM is soldered down, right? So it's not DIMM. So you can't bring your own VRAM, and so you would still like it's complicated.
Yeah. Yeah. It's not straightforward.
The work continues.
Yeah. That's where that's where we're not at the relief point quite yet, but soon.
Yeah.
Well, thank you both for your time. Yeah, it's been really interesting, enlightening, and good luck. Good luck getting these out there to users. So let's talk about performance on Steam Machine. And what's interesting is AMD's components that they've chosen here, at least the comparable, discrete components that you can buy, like the RX 7600. Performance there is kind of a known quantity. They're really good. entry mid-range parts where you can be assured that 1080p performance is no problem. And in fact, SteamOS by default will run games at 1080 on the Steam machine. You can go into on a per game level or system-wide level to say the default resolution can be bumped up to native resolution, but it's something that you kind of have to dig into. So whether you have it plugged into an ultra-wide monitor or a 4K TV, by default, it's going to output and try to perform at 1920 by 1080. And at 1920 by 1080, I was able to max out basically all my settings in any game I threw at this. High settings, ultra settings, with FSR upscaling turned off. Didn't need frame gen, didn't need FSR turned on, and was able to get well above 60 frames per second in every game I played, achieving up to 80 and 90 frames per second with FSR turned on. No problems there. Where you start having to choose in the performance settings and whether you want to use upscaling is when you move into 1440 and 4K resolutions. And so did a bunch of testing at 2560 by 1440 as well as on a ultra wide, so 3440 by 1440, similar number of pixels. And in those settings, you could still play at high graphic settings. Maybe not the ultra graphic settings you're used to, but in games like older games like Red Dead Redemption 2 or Cyberpunk 2077, Doom: The Dark Ages, or even modern games like the James Bond First Light game or Forza 6, I was able to max out high graphics settings, ray tracing turned off most of the time, and with FSR on, was able to get well into 60 frames per second on average. You're really going to get about 40 to 60 frames per second if you have FSR turned off at 1440p, but FSR turned on, 60 FPS becomes no problem. At 4K resolution, here's where upscaling FSR is really needed and where you really have to make choices about the features in the games you want to turn on and off. Because at that resolution and choosing things like high-res textures, you're going to run into the limits of not only the CUs, but also the VRAM, the 8 gigabytes of VRAM here. And most modern games, as you tune the settings, you can actually see a slider in a bar for how much memory is being consumed. And with a new update in SteamOS that actually just came out as we're recording this, Valve has improved the memory management to better allocate memory between VRAM and DDR5 RAM when you're exceeding the 8 gigabytes, something they didn't have to worry about when they were designing for the APU of the Steam Deck. But that's to say that at 4K resolution, I had mostly my graphics on medium settings, ray tracing off, and with FSR turned on was getting in the 50 to 60 frames per second, which I still found was pretty impressive, but with FSR turned off was dipping down in the 20 and 30 frames per second. Not very playable for even games like Cyberpunk 2077, which is already a couple of years old now. And the use of AMD's FSR upscaling becomes an interesting choice for gamers because compared to NVIDIA's DLSS, FSR in at least for RDNA 2 and RDNA 3 graphics cards, that's FSR 2 and 3, really hasn't shown the same level of consistent image quality as DLSS. It's more prone to visual artifacts as you tune between performance and image quality. Something we were not able to test and that did recently get announced is AMD said that RDNA 3 graphics cards, so like the one in the Steam machine, will get support in the coming months. I think they said July for SFR 4. And in what people have used and tested of FSR 4 for RDNA 4 GPUs, the image quality is much better at the same performance benefit. We don't know what that's going to look like until we can actually run that on Steam Machine, and Valve can only say that support is coming and coming soon, but hopefully that will make turning on FSR less of a decision you'll want to be making and just a no-brainer. You'll just want that performance benefit of the upscaling and not have to worry about image artifacts. And to be honest, the image artifacts compared to what you see on like a game console, a PS5, and the upscaling it does there, is pretty standard. I mean, it may not be the perfect pixels and what you're used to on a high-end gaming PC, but upscaling is a part of most game engines now to some extent, and it's part of how game consoles have been able to maintain 30 or 60 FPS when running on 4K TVs for the longest time. And so this has basically that kind of image quality parity with something like a PS5 or a PS5 Pro. And in many ways, the Steam Machine operates like a console more than a gaming PC. SteamOS as your user interface, I think, still kind of walks that line between desktop OS UI and game console UI, but it's fully navigatable with a gamepad, and you can have things like it automatically going to sleep, and the power consumption drops from 50 to 60 watts at idle to under 1 watt when it's in sleep mode, with nice features like the ability to make sure it's still downloading content in the background before it fully goes to sleep. These are all very console-like features. One thing I wish the Steam Machine had was a handle, and maybe it's just a byproduct of me wanting to test it in different environments in this past week and a half, but moving it between the living room to my office to even trying it in different places around the house, it kind of can fit anywhere. Kind of in the way that Apple's Mac Mini has this versatility of where it can work great on a desktop, but also can work as almost as a traveling computer. I can imagine the Steam Machine working as a traveling dedicated gaming system. It also works as a streaming receiver, so if you have already a big beefy gaming PC, you can stream games to it, and it can stream games to devices. I mean, you can plug in display glasses, which run at 1080, can run any game basically in the Steam library, but I was also interested in seeing how it works streaming to VR headsets. Now, we don't have Steam Frame quite yet, but the comparable equivalent would be something like a Quest 3, and Steam Link works great on the Quest as well as the Apple Vision Pro. And so you can stream flat screen games to those devices, to VR devices, having a virtual giant monitor, which has worked well with other devices. But here, running those at 1440p looks really nice in headset. To run full PC VR games natively, though, I found a little bit more problems. I could use Steam Link to connect the Quest 3 to the Steam Machine to stream something like Half-Life Alyx, but Steam Machine doesn't have a dedicated wireless radio like the Steam Frame will have, that USB stick for foveated streaming. But your experience in VR games will depend a lot on that wireless connection. Half-Life Alyx as a game ran fine in high settings, but I wasn't running this at twice the resolution of the Quest 3 and using super sampling. It definitely doesn't have the horsepower for that. And unfortunately, SteamOS, even in desktop mode, didn't get it working with Big Screen Beyond, and support for even things like Valve Index is a little bit iffy. It does technically work, but very clearly not a machine made for plugging VR heads directly into it. So let's talk about pricing. There are 4 models of the Steam Machine you can buy, and it starts at over $1,000, $1,049 for the 512 gigabyte model. You have to add $300, so that's $1,349 for the 2 terabyte model, which while that seems like a lot, I think you'd be hard pressed to find a 2 terabyte SSD for much less than that. And the 2 terabyte Steam Machine does come with the 2 additional faceplates. And then the 2 other SKUs are the versions of those Steam Machines with a bundled Steam controller, which is the version I would recommend if you're really in the market for this. The Steam controller add-on for that ends up being $79, which is $20 cheaper than the Steam controller by itself. And availability of Steam controller is already pretty limited. I think people who made a reservation to buy theirs recently in these past couple of weeks might not get their Steam controller till the end of the year or even early 2027. That's how in demand they are. And Valve expects demand and availability of Steam Machine to be pretty limited as well, as components are harder and harder to source and more expensive. And so the reservation system they're launching today is going to be for a lottery that's going to be on Thursday to create the order queue for people to order a Steam machine. All that's to say that it's really early for this box, even though it is older hardware and something that Valve's been working on for years. And even in SteamOS, I can see the updates coming pretty frequently over this past week and a half. There are things that we still don't know, we're still yet to test, and we're curious about, like image quality of FSR upscaling on RDNA 3 here, as well as optimizations to ray tracing that Valve has just recently dropped, and things like better RAM management when you're running at 4K and high-res textures. SteamOS, I think, is pretty mature as a desktop and OS and even a big screen OS, but I still think graphically there could be some improvements, and Valve is pretty fast to push out those updates. The whole exercise of building this hardware, I think Valve has achieved what they set out to do, making something small, compact, really quiet, low power consumption. But all of that is, and they'll say it as well, is to build out the ecosystem of SteamOS, to let more people build SteamOS machines, not just Radeon graphics machines, but NVIDIA machines eventually, or Intel machines eventually. And Linux as a gaming operating system is way more viable today. And a lot of that is thanks to the compatibility layer work that Valve and the Proton team has done. So you worry less about compatibility with games, especially new AAA games, except for the multiplayer game that needs easy cheat on the kernel level. And there are more options than SteamOS too. Bazite's a really popular option that has NVIDIA graphics support, as well as better support for other game stores outside of Steam. And so if you want to experiment in Linux as a gaming OS, if you want to drop Windows as the chokehold for gaming, it's very easy to download a distro and dual boot into one of those just to try out and see what that performance is like. All that to say, it's hard to recommend this machine at this price for just purely on the performance level. There's a lot to love about the ease of use and how great it works out of the box and the small form factor and things that you can't achieve if you're just building your own gaming PC. But everyone's going to have to decide for themselves whether those design flourishes and all that engineering work that Valve did is worth that extra price, because this is certainly much more expensive than what Valve had originally hoped that this would launch at. But that's the state of the world these days. If you have questions about Steam Machine, and we certainly are curious about Steam Frame and have yet to test that with this, let me know in the comments below. But otherwise, thanks so much for watching, and I'm Norm, and I will see you next time. Bye.
We put out a video every single day, and you can subscribe by clicking on the link.